Welcome everyone. In this video, I am going to discuss periodic functions and its application in definite integration. Before we start, we need some basic concepts. So, what is periodic function? A function f(x) is said to be periodic of period lambda if f(x) equals to f of lambda plus x. So this is definition of periodic function. f(x) equals to f lambda plus x. Lambda is period. Suppose f(x) equals to sin x. So f 2 pi plus x equals to sin 2 pi plus x equals to f(x). Therefore, sin x is a periodic function of period 2 pi. So, sin 2 pi plus x, so look, lambda plus x, so period is 2 pi. So, sin 4 pi plus x is also sin x. So, period is 4 pi, but in this case, we take list of them. So, to solve problem of definite integration using properties of periodic function, we need period of some functions. So, trigonometric functions. So, sin x function sin x. And what is period? Sin ax, period is 2 pi by a. This is general. If a equals to 1, now sin x period 2 pi. Cos ax, 2 pi by a. Tan ax, tan pi plus x is tan x. So period is pi. Cot ax, pi by a. So cosec ax, period is again 2 pi by a. And sec ax, period is 2 pi by a. So this is general one. For example, period of cos x by 2. So 2x by half is 4 pi. So periodic function of trigonometric functions. Now, period of mod sin x. Mod sin x. So sin pi plus x is minus sin x, but due to presence of mod, period is pi. So what is period? Period is pi. Similarly, mod cos x, period is pi. Mod sin x plus mod cos x. So look, pi by 2 plus x is cos x. Cos pi by 2 minus x is minus sin x. So due to presence of this, period is pi by 2. So greatest integer function x, period is 1. Fractional function, period is also 1. Fundamental period 1. And if f(x) has a period, if f(x) has a period a, then e to the power f(x), this also has same period. So we use this theorem also. f(x) is a periodic function of a, then e to the power f(x) is also periodic function of period a. These are the basic ideas we need. Then property of periodic function. So look, property 0 to nt f(x) dx equals to n outside 0 to t f(x) dx. So when f(x) is a periodic function of period t, that is fx equals to fx plus t. So this is property of periodic function. So from this property we can deduce some deductions. So what is deduction 1? A to a plus nt fx dx n into 0 to t fx dx. Here also, so same condition, fx equals to fx plus t. mt to nt fx dx equals to n minus m 0 to t fx dx. Here mn belongs to I, integer. A plus nt to b plus mt fx dx equals to a to b fx dx. And deduction 4, nt to a plus nt fx dx equals to 0 to a fx dx. So this is main property, 0 to 2 this. Using this property, now we try to solve some important problems of board as well as competitive examination. Now we apply the property of periodic function in some problems. Look, application. Problem number 1. 0 to 400 pi root over 1 minus cos 2x 800 root 2. 0 to 100 pi root over 1 minus cos 2x 200 root 2. 0 to 32 pi by 3 root over 1 plus cos 2x dx. So these are of exactly same type. So we consider 1a. So 0 to 400 pi root over 1 minus cos 2x. So this equals to 0 to 400 pi. Now root over 1 minus cos 2x, 2 sin square x dx. 2 sin square x dx. So this is root 2 outside, 0 to 400 pi mod sin x dx. Now this is not sin x, because if it is in first quadrant then it is sin x. So this is mod sin x. Now we know mod sin x is a periodic function of period pi. So by the above property, so 400 will come before integration. So 400 root 2, 0 to pi mod sin x dx. Now within 0 to pi mod sin x is positive. So 0 to pi sin x dx. Now 400 root 2 minus cos x 0 to pi. So this is 800 root 2. Cos pi is minus 1, minus plus cos 0 is 1. So this one. So this is mod sin x from 0 to n. So n comes before integration. Now second one is exactly similar. Look, answer is 800 root 2. If it is 10, 100, then it is 200 root 2. If it is 55, then 100 root 2, and so on. So look, property, using this property, we solve problem number 2. So look, this one, this is fraction, 32 pi by 3, 32 pi by 3. So this is 10 pi plus 2 pi by 3. So 10 pi is integer. So integer part you can write. So 0 to 10 pi by property root over 1 plus cos 2x plus 10 pi to 10 pi plus 2 pi by 3 root over 1 plus cos 2x dx. Now this one, 2 cos square x. So root 2 outside, 0 to 10 pi mod cos x dx plus root 2 10 pi to 10 pi plus 2 pi by 3 mod cos x dx. Now, by the previous property, mod cos x is periodic function of period pi. So 10 root 2 0 to pi mod cos x dx. And from deduction, na to na plus t. So root 2, so 0 to 2 pi by 3 mod cos x dx. Now 0 to pi mod x is not positive, so again you write this one as 10 root 2 0 to pi by 2 mod cos x plus 10 root 2 0 to pi by 2 pi by 2 to pi mod cos x, and root 2 0 to pi by 2 mod cos x dx plus root 2 pi by 2 to 2 pi by 3 mod cos x dx. Now this one is positive, this is negative, positive, negative. So putting value, we get answer. Or we can use shortcut method also. 0 to pi mod cos x equals to 2. Similarly 0 to pi mod sin x dx equals to 2. So this is problem number 2. Now 3, 4, 5, they are of same type. So we consider problem number 4. So problem number 4. So we have already stated. So what is our problem? 0 to 100 e to the power x minus third bracket x dx. So x minus third bracket x, this is fractional part. Fundamental period is 1. So x minus third bracket x, period 1. Period is 1. So 100 come before. So if x minus third bracket x is a periodic function of period 1, then e to the power fx, so e to the power x minus third bracket x will have same period. So 0 to 1 e to the power x minus third bracket x dx. So in 0 to 1, you look 0, third bracket x equals to 0. So we get 0 to 1 e to the power x dx. So 100 into e to the power x 0 to 1. So 100 into e minus 1. This one. So problem number 5. Problem number 5. So this is most important problem. So look for competitive exam also. So exactly same that of earlier. Look 5, 0 to third bracket x. This is greatest integer. 2 to the power x by third bracket x. 2 to the power dx. So by rule of indices, 2 to the power x minus third bracket this. Now x minus third bracket x, it is periodic function of period 1. Therefore 2 to the power x minus third bracket x will have period 1. So root of third bracket x outside 0 to 1, 2 to the power x minus third bracket x dx. So third bracket x, and we have already discussed, this will be only x. So integrating, we get 2 to the power x by log 2, 0 to 1. So x by log 2, third bracket x by log 2, 2 to the power 1 minus 2 to the power 0. So third bracket x by log 2. Third bracket x by log Now we consider an important property of periodic function. So look, if fx is a periodic function of period a, then a to a plus t fx dx is independent of a. Fx is a periodic function of period a, then this one is independent of a. So what is our integral? So integral is I equals to a to a plus t fx dx. So we have to prove this is independent of a. So we put a transformation. Let x equals to a plus z. So dx equals to dz. Then if we change the limit, if x equals to a, z equals to 0. A plus t, z equals to t. So what we are getting? 0 to t, f, a plus z dz. Now, since it is a periodic function of period a, f a plus z is again fz. Fz, since f a plus z equals to fz. Fz, now 0 to t fz dz. This is 0 to t fx dx. By property, here it is demi-variable. Now this relation is independent of a. Therefore, it is independent of a. This is independent of a. Now using this theorem, we solve a problem. So, what is our next problem? Look, a to a plus pi by 2 sin to the power 4x plus cos to the power 4x is independent of a. So same proof. I equals to a plus pi by 2 sin to the power 4x plus cos to the power 4x dx. Now sin to the power 4x, if we change it pi by 2 plus x, this is cos to the power 4x, and if we replace x by pi by 2 plus x, this is sin to the power 4x. So no change. So it is periodic function of period pi by 2. Or we can express this in terms of multiple angle, then we can find period. So it is expressible in terms of cos 4x. Actually it is expressible in terms of cos 4x. So period is 2 pi by 4, that is pi by 2. So this one, it is a periodic function of period pi. So by the above theorem, so look, ASM, if it is periodic function, sin to the power 4x, cos to the power 4x. What is period? Period is pi by 2. So by the above theorem, this is 0 to pi by 2, sin to the power 4x, cos to the power 4x dx. Now this relation is independent of a. So this is independent of a. Now problem number 9. This one. So 0 to n pi to t. So here it is given t lies in first quadrant. There is a restriction also. 0 to this. So look, we can write this integral as 0 to n pi mod cos x plus mod sin x dx plus n pi to n pi plus t mod cos x plus mod sin x dx. Now mod cos x plus mod sin x, this is periodic function I have already discussed of period pi. So n pi can be written as 2n into pi by 2. So period pi by 2. So 2n will come before integration. So this is 2n 0 to pi by 2 mod cos x plus mod sin x dx, and by the above deduction, so previous deduction, so n pi to t, so by the previous deduction, this is mod cos x plus mod sin x dx. Now in 0 to pi by 2, both mod is positive, so 2n 0 to pi by 2 cos x plus sin x dx, and since t lies between 0 to pi by 2, this is cos x plus sin x dx. So integrating we get a result. So this problem is the most important problem. Now we consider some more applications. So problem number 10, 11, 12, 13. Both are equally important for competitive exam. So we consider problem number 12. So this is same as of previous problem. Here period of the function is not given directly. Here a functional relation is given. So what is functional relation? Problem number 12. fx plus fx plus 4 equals to fx plus 2 plus fx plus 6. I think this is fx plus 6. This is fx plus 6. So replacing x by x plus 2, what we are getting? So look, fx plus 2, this is fx plus 6, this is fx plus 4, and this is fx plus 8. So call it 2. So equating 1 and 2, if we equate, then look, fx plus 4 left hand side and right hand side fx plus 4. So cancel out. Fx plus 2, fx plus 2 cancel out. Fx plus 6, fx plus 6 cancel out. So from 1 and 2, what we are getting? Fx equals to f of x plus 8. So what is the period? So period of fx equals to 8. Now from this functional relation, we can prove that period of fx is 8. Now I equals to, so what is I? I equals to, this is our problem, x to x plus 8 ft dt. So from deduction of the property of periodic function. So look, we have already proved a to a plus t fx dx is independent of a. Here a is replaced by x. So it is 0 to 8 ft dt. 0 to 8 ft dt. So if we integrate, we get, so what is upper limit? Upper limit is constant, lower limit is constant, so it is constant. So this is our proof. So look again, fx be a real valued function satisfying this, x to x plus 8 ft dt is constant function. So from this equation, we are getting fx equals to fx plus 8. So period is 8. So I equals to x plus 8 ft dt. We have already proved this result. If it is periodic function of period 8, then it is x will be absent. It is 0 to 8 ft dt. So this one is constant. Now problem number 13. Problem number 13. So look, here also a functional relation is given. So what is functional relation? Fx plus fx plus half equals to 3. So call it 1. So replacing x by, it is obvious that you have to replace x by x plus 2. So what is, this is fx plus 2 and this is fx plus 1 equals to 3. So look, 3 cancel, fx plus f cancel. So 1 minus 2 implies fx equals to fx plus 1. So what is the period? Period is 1. Now you have to prove this equals to 150. So I equals to 0 to 100 fx dx. So since it is periodic function of period 1, so 100 come forward. So 0 to 1 fx dx. So in some time problem is given in this form. Prove that 100 into 0 to 1 fx dx. But here you have to prove this as 150. So write 100 0 to half fx dx plus half to 1 fx dx. So 100. Now we put a transformation. So x equals to z plus half. X equals to z plus half. So if we put x equals to z plus half, so dx equals to dz. And if we change the limit, look, x equals to half, z equals to 0. X equals to 1, z equals to half. So what we are getting? 100 0 to half fx dx. Half to 1 f z plus half dz. So this one. Then the 100 first function unchanged, 0 to half fx dx. Second one is also. So if it is half, then it is 0. We have already proved it. And if it is 1, then it is half. Sorry. So this is 0 to half again. And this is x plus half. X plus half dx. Now look, here it is Jam variable. Now both the limits are same. So 0 to half, this is fx plus f of x plus half dx. Now from the given functional relation, so this is 3. So 0 to half 3 dx. So integrating we get result. So 100 3x half to 0. So 100 into 3 by 2 150. So this is our proof. Now problem number 11. So this is very simple problem. We have already solved this one, but given in different form, in summation form. So look, if we put for this problem n equals to 1, n equals to 1, so this is 0 to 1, e to the power x minus third bracket x dx. If we put n equals to 2, 1 to 2, e to the power x minus third bracket x. And similarly in this, if we put 1000, so this is 999 to 1000 e to the power x minus third bracket x dx. So look, these diagonals are same. So if we add them, we get 0 to 100, 0 to 1000 e to the power x minus third bracket x dx. So 1000 outside, because we have already considered e to the power x minus third bracket x, it is periodic function of period 1. So e to the power x minus third bracket x dx, and within 0 to 1, third bracket x is 0, so what we are getting, 1000 into e minus 1. So using property of periodic function, look, we have already solved many problems. So you try to solve rest of the problems. If you want to get such type of videos, please share and subscribe to my channel. Thank you.